Good morning to everyone. Can able to hear me? Good afternoon.
Good afternoon, sir.
Yeah, good afternoon. How was today's exam? Hello. Today's exam. How was today's exam? Can able to hear me?
Yes, sir.
Yeah. Yesterday I was teaching the extra class hydrogen and its compounds. Is it correct? Hydrogen and its compound. Even I completed yesterday important compounds of sodium. Important compounds of sodium. Any doubts is there in the important compounds of sodium? Please tell me. Are hydrogen its compounds? Any doubts is there? Hydrogen its compounds, otherwise important compounds of sodium. Any doubts? Please let me know. Which topic should I repeat? Which one? Hello? Please tell me, ma'am. Which one can I discuss? Important topic, important compounds of sodium. In that I started first sodium hydroxide preparation. This is called caustic soda preparation. Caustic soda, there are two types of preparation, is there? One is Nelson's cell process, another one is Kastner-Kellner process. Kastner process, Nelson cell process, Kastner-Kellner process, and then I started sodium carbonate decahydrate. This is called washing soda. Washing soda, sodium carbonate decahydrate. This is solvase process. Preparation is solvase process. I completed that method. And sodium bicarbonate NaHCO3, that is called baking soda. Baking soda, this is called sodium bicarbonate, otherwise it is called sodium hydrogen carbonate. Preparation I completed. Next, NaCl. NaCl is called sodium chloride. Sodium chloride, otherwise it is called brine solution. So brine solution, or otherwise it is called rock salt, otherwise it is called common salt. So those preparation also I completed. Even along with this one, I completed this one also. Na2SO4.10H2O, Glauber salt. This one also I completed. In this compounds, any doubts is there? Please let me know first. Which one should I teach in the Kastner-Kellner process, Nelson cell process? Otherwise, sodium carbonate decahydrate preparation, that is always process. Otherwise, sodium bicarbonate preparation or sodium chloride brine solution preparation or sodium sulfate NH2O, Glauber salt, sodium sulfate preparation. Which one should I teach? Tell me, please. No doubts? Hello? Please tell me any doubts or no doubt?
No doubt, sir.
Yeah. In that hydrogen and its compounds. Yesterday I started in the hydrogen and its compounds. The hydrogen and its compounds, yesterday I completed position of hydrogen in periodic table. Position of hydrogen in periodic table. And after that, it has similarity with
Yes, sir.
hydrogen. Hydrogen has similarity with hydrogen has similarity with alkali metals. Some evidence I showed to you. And even hydrogen has similarity with the halogens. 17th A group elements. That evidence also I told you. Even hydrogen difference with alkali metal. Hydrogen difference with alkali metal. Difference with alkali metals I told you. And hydrogen difference with halogens also I told you. Any doubts in this part? Different with halogens also I told you. In this part, any doubts is there? Please let me know first.
No, sir.
No. Next, occurrence of water. What is the occurrence of hydrogen?
So what are you doing, sir?
Hello?
Hello, sir. What are you
Hello?
doing now, sir?
So still I didn't start. Yesterday, whatever the topics I covered, that I am telling. Hello?
Okay, sir.
Till now, whatever the topics I covered in the S block element and hydrogen its compounds, that I was telling. I didn't start in any topic. Occurrence of hydrogen, dihydrogen occurrence. What is the dihydrogen occurrence? Can anyone tell me, please? Hydrogen is ninth most abundant element. Ninth most abundant element in the earth crust. Hydrogen is ninth most abundant element in the earth crust. Ninth most abundant element in the earth crust. Next, what are the isotopes of hydrogen? Can anyone tell me what are the isotopes of hydrogen? Please let me know what are the isotopes of hydrogen. You know 1H1, 1H2, 1H3. 1H1 is called protium. 1H2, otherwise it is called 1D2 deuterium. Deuterium. 1T3 tritium. 1T3. Here, one electron. Everywhere one proton is there. One proton, one proton. One electron, one electron, one electron. Here, zero neutron, one neutron, two neutrons. Is it correct? This is the radioactive element. Tritium is the radioactive element. Correct or not? Radioactive element. This half-life is 12.33 years. T off value of tritium is 12.33 years. Yes, clear this points. What is the order of reactivity of isotopes of hydrogen? Order of reactivity. Order of reactivity. Hydrogen is more reactive than deuterium, than tritium. So here, protium has one proton, one neutron. There is no, sorry, one proton, one electron. There is no neutron. Deuterium, one proton, one electron, one neutron. Tritium, one proton, one electron, two neutrons will be there. This is called radio tritium. This is will release alpha beta rays, beta particle will release. Yeah, next, after this, I started hydrides. Did I started hydrides? There are three types of hydrides are there. I told like that. What are the types of hydrides are there? Hydrides means. Can you tell me please what are the types of hydrides are there? What are the types of hydrates are there? Ionic hydride. Otherwise it is called saline hydride. Saline hydride. Covalent hydride. Covalent hydride. And last one is called interstitial hydride. Otherwise it is called metallic hydride. Metallic hydride. Otherwise, it is called interstitial hydrides. Ionic hydride or saline hydride means I already told you. S block elements. S block elements combines with hydrogen will give rise to saline hydrides. Saline hydride, otherwise it is called what type of hydride? Ionic hydrides. So in this saline hydride or ionic hydride, example LiH type of hydride, NaH type of hydride, and KH type of hydride, RBH type of CS type H type of hydrides will form. This is first A group elements hydrides. And even second A group element hydrides will form, that's called second A group element hydrides. BeH2 type of hydride, MgH2 type of hydride, and CaH2 type of hydride, and SrH2 type of hydride, BaH2 type of hydride, like this type of hydrides will form here. Like first A group. This is called all are saline hydrides. Please listen, one more point is most important here. Lithium hydride and beryllium hydride and magnesium hydride. These three hydrides are covalent nature. Covalent nature of hydrides. That three hydrides, remaining hydrides are called NaH, KH, RBH, CSH, CaH2, SrH2, and RBH2. All are what type of hydrides means? Sorry, BaH2. All are what type of hydrides? Ionic hydrides. These all are called saline hydride. Saline hydride, this is water soluble substance. Generally, ionic substance are water soluble substance. Is this clear? This point? This is called ionic hydrides. Is clear?
Yes, sir.
Let me know. Is clear or not? Once you're done, you can inform to me. I'll go to next one. Hello? I completed.
Sir, just
Completed, ma'am.
no, sir.
Is it completed or not?
No, sir. 1 minute. Sir, done.
Okay, sir.
Hello? Please respond.
Done, sir.
Done. Okay, next, listen. Generally, beryllium hydride and magnesium hydride both are polymeric structure. Polymeric structure. This is the structure. Hydride. This is the structure. Polymeric structure. Beryllium hydride is polymeric structure. Even magnesium hydride also polymeric structure. This is the magnesium hydride. Magnesium hydride also polymeric structure. Polymeric structure. These two are covalent nature. These two are covalent nature. And CaH2. CaH2 one special name is there that's called hydrolith. What is the commercial name of CaH2? Hydrolith. The stability. What is the stability of hydride? Stability of hydride. LiH and NaH, KH, RBH, CSH. What is the stability of hydride? LiH is more stable than NaH, then KH, then RBH, then CSH. This is the stability order. Stability of hydrates decreases and increases. Stability of hydride. The stability of hydride decreases. Decreases, the size of cation increases. The size of cation increases. Cation size increases, stability of hydride, what will happen? Decreases.
Okay, sir.
Yeah, next one, please listen. Lithium hydride, whenever lithium hydride react with Al2Cl6, aluminum trichloride, will give rise to lithium aluminum hydride. This is a strong reducing agent. Strong reducing. So please listen. Lithium hydride react with Al2Cl6. Lithium aluminum hydride plus LiCl will form. Due to the formation of lithium aluminum hydride, this is called strong reducing agent. Even lithium hydride react with B2H6 diborane. B2H6 diborane will give rise to lithium borohydride. Lithium borohydride is also strong agent. Strong reducing agent. Generally, saline when sodium hydride react with water hydroxide plus hydroxide react with carbon monoxide will give rise to HCOONA, sodium formate. Sodium formate will form plus carbon will form. Due to the formation of carbon, it is a strong reducing agent. Strong reducing agent. Please note these 3 points. Lithium aluminum hydride react with Al2Cl6 will give rise to lithium aluminum hydride. Lithium aluminum hydride is the strong reducing agent. Lithium react with B2H6 will give rise to lithium borohydride. That's also strong reducing agent. While coming to sodium hydride react with water, sodium hydroxide plus hydrogen gas. When sodium hydroxide react with carbon monoxide, will give rise to sodium formate and hydrogen carbon. So due to the formation of carbon, that sodium hydroxide acts as a powerful reducing agent. Powerful reducing agent. This is about ionic hydride, otherwise it is called saline hydride. Saline hydride, otherwise it is called salt hydride. This is the salt hydrates. I hope these points are clear. Next, I'm going to covalent hydride. Yes, can I start covalent hydride? Covalent hydride, please slow down. Can I start covalent hydride? Yes.
In that, which is strong, the last equation, which is strong reducing agent?
So due to the formation of carbon, NaH acting as a strong reducing agent. Next, covalent hydride. Please slow down. Covalent hydride. Otherwise, it is called molecular hydride. Covalent is molecular hydride. What is the meaning of covalent hydride and molecular hydride?
1 minute, just 1 minute. Okay, sir.
Yeah, thank you. Covalent hydride. Covalent hydride are molecular hydride. Covalent hydride or molecular hydride means generally P block elements like 13th to 17th group elements, 13th group element, 14th group element, 15th group element, 16th group element, 17th group element react with hydrogen. React with hydrogen to give covalent. Covalent hydride otherwise is called molecular hydride. Molecular hydride. For example, there are three types of covalent hydrides. What are the three types of covalent? Please listen here. First one is electron deficient hydride. Electron deficient hydride, or this is called Lewis acid. This is called electrophiles. Electron deficient molecules. Next, electron precise hydride. Electron precise hydride. And third one is electron rich hydride. Electron rich hydride otherwise is called nucleophile. Nucleophile otherwise is called Lewis. There are three types of hydride: electron deficient hydride, electron precise hydride, electron rich hydride. Electron deficient hydrides otherwise is called Lewis acid. Electrophiles, electron deficient molecules. Electron deficient, that's what is called electrophiles. Electron hydrides. This is the excess of electrons, that's why it's called nucleophiles. Excess of electrons will be there. Is it clear at this point? Now can I discuss the types of covalent hydride? Once you are done, you can hop on to this. completed. Once I'm done, it will come to
Yes, sir.
everyone completed.
Yes, sir.
Yeah. Now, electron diffusion type. Electron diffusion means typically this cycles is in the group. You know all atom group elements like boron, aluminum, gallium, indium, that. React with hydrogen. React with hydrogen. Give you electron diffusion types. Electron diffusion type. For example, BHD, ALHD, DHD. These are not one type of electron diffusion. First of all, outer motion there are 6 electrons. That is why it's called one type of hybrids. Electron diffusion. This is called as electron diffusion hybrids. Electrophiles. Around the central metal atom, only 6 electrons are there. It is insufficient for octet configuration. Incomplete octet configuration. Income. So that's why it is called electron diffuse. I hope these hydrates are clear. Next one, electron precise hydrate. Second one, electron precise. Electron precise means electron precise hydrates means generally 14th group element. They react with hydrogen. To give electron precise hydrate. Electron precise hydrate. Example of electron precise hydrate: CH4, SiH4, like this type of compounds. SiH4, CH4. See, around the carbon atom there are 8 electrons. That's why it's called electron precise. Even around the Si there are 8 electrons. That's why it's called electron precise hydrates. It has octet configuration. Outermost 8 electrons will be there. Please complete once you done, you can come to me.
Sir, what is it after the indium in second line?
What?
The second line, what is it after the indium, sir?
14th group element react with hydrogen, give electron precise hydrates. Electron precise boron, aluminum, gallium, indium, thorium with hydrogen will give electron deficient hydrates.
Okay, sir.
Hello.
Okay, sir. Thank you.
Okay, sir.
Yes, completed. Next, I am going to electron rich hydrates. Generally, electron rich hydrates. So generally, electron rich hydride, 15th group element, 16th group, 17th group elements. Group elements react with hydrogen, to give electron rich hydrate. Electron rich hydrate. According to Lewis concept, electron rich hydrates are called Lewis base. Otherwise, it is called nucleophile. Electron nucleophiles. So example for this type of hydrides in 15th group NH3, in 16th group water, in 17th group HF. Please listen why it is called electron rich species. Nitrogen having one lone pair of electron, oxygen having two lone electrons, fluorine having three lone pair of electrons. Due to presence of lone pair of electrons, it is called what type of compounds? This is Lewis bases, nucleophile. This is called electron rich species. Electron rich species. So in this 15th group element, PH3, NH3, PH3, all these compounds are called electron rich hydrides. Even in 16th group elements, H2O, H2S, are having lone pair of electrons. That's why it's called electron rich species. H, electron rich species, of having three lone pair of electrons. Is it clear this point? This is called covalent hydrides, otherwise it is called molecular. Otherwise it is called molecular hydrides. Next, I am going to next one, interstitial hydride. Otherwise it is called metallic hydride. Otherwise it is called non-stoichiometric hydrides. What are the non-stoichiometric hydrides? Once you complete, you can inform to me. Completed. Hello. Okay. Can I erase this page?
Yes, sir.
Next, metallic hydride. Metallic hydride, otherwise it is called interstitial hydride. Interstitial hydride, otherwise it is called non-stoichiometric hydride. Non-stoichiometric hydride. Non-stoichiometric hydride. Many D and F block elements. D and F block elements. Many D and F block elements are formed metallic hydrides. Metallic hydride. That is stoichiometric ratio. What type of non-stoichiometric ratio? What is the meaning of stoichiometric ratio? So that means the ratio of metal atom and hydrogen is not equal. That is called non-stoichiometric ratio. The ratio between metal and hydrogen, not same. That is called non-stoichiometric ratio. Example for metallic hydrides or non-stoichiometric hydrides: chromium hydride, COH, lanthanum hydride. The lanthanum hydride in bracket 2.867 is there. So hydrogen is 2.67, lanthanum is different ratio. Zirconium hydride, yes, ZRH. Zirconium hydride, 1.3 zirconium hydride. So this is called what type of hydrates example? Metallic hydrates example. Many of the D block element and F block elements reaction with hydrogen will form hydrates. That's called metallic hydrates, otherwise it is called interstitial hydrate, otherwise it is called non-stoichiometric hydrates. What is the meaning of non-stoichiometric hydrate? Means the ratio of metal and hydrogen is different. That's called non-stoichiometric hydrates. After this, I'm going to water. Water. Please fast. Complete fast.
Done, sir.
The next, water. Water, you know very well, H2. Can you tell me what is the important source of water? What are the important source or occurrence? Source for water? Oceans. Is it correct? Oceans is 97.33%. This is the important source of water. You know, groundwater, lake, groundwater, river. These are the important source of water. Important source of water. You know, while coming physical properties of water, what are the physical properties of water? Can anyone please? And one more point I need to tell to you. Purest form of natural water is rainwater. Which one is the purest form of water? Purest form of water. Purest form of water is natural water, rainwater. Rainwater is the purest form of water. That is called natural water. Human body, please note this point. Human body is made about 65% of water. Human body has about 65% of water. Some plants has 95% of water. 95% of water. You know H2O molar mass is 80. H2O molar mass is 80. You know H2O melting point is 273. 0 degrees Celsius. Boiling point is 100 degrees Celsius. T7 373 Kelvin. And D2O, you know deuterium. D2O means what? H2O normal water, D2O heavy water. H2O molar mass is 18, D2O molar mass is 20.02. This melting point is 276.8 Kelvin. This melting point is 273 Kelvin. This is boiling point of Kelvin. This is 374.4 Kelvin. 374.4 Kelvin. H2O is electrical conductivity, but D2O is not electrical conductivity. H2O is electrical conductivity. Is it clear? This is about some physical properties of water and D2O. Any properties of water? Please listen now. Some chemical properties of water.
Sir, 1
You
minute,
know,
sir,
I
1 minute,
hope
sir.
these points are clear. Source or occurrence. Yeah, what is the important occurrence of water? Ocean, lake, groundwater, river, like that. What is the physical property? Purest form of water is called, what is that? Natural water is called rainwater. Human body is made up of 65% of water. Plants is made up of 95% of water. Water molecular mass is 80. Melting point is 273 Kelvin, otherwise it is called 0 degrees Celsius. Boiling point is 100 degrees Celsius, 373 Kelvin. And D2O, this is called AV water. AV water density is 20.02 and melting point is 276.8 Kelvin. Boiling point is 373.4.4. But water is electrical conductivity, but D2O does not conduct electric. Completed.
Yes, sir.
Yeah. Chemical properties of water. Can I take 10 minutes or can I take tomorrow? Tell me your wish. Can I take class tomorrow? If you are everyone joining means I'll take, otherwise I will not take the class. Everyone should join the class, then I will take, otherwise I won't take tomorrow. Your wish. It's your hand. If you are joining everyone, I'll take tomorrow class. I will time this in the WhatsApp.
Sir, you take 10 minutes, sir.
What ma?
You take 10 minutes, sir. Because,
Now I will take 2 minutes. I will take tomorrow. Is it fine?
okay, sir.
Even tomorrow. Hmm?
Okay, sir.
Yeah. Please note down chemical properties. Chemical properties of water. So generally, water acts as an acid as well as base. You know very well. Water acts as acid as well as base. As well as base. Why? And hence this is called and hence known as amphoteric nature. Amphoteric substance. That's why water is called amphoteric substance. Why it is called amphoteric substance? So water will react with acid as well as base. H2O react with acid and as well as base. H2O react with NH3 will give rise to. NH3 will give rise to OH minus plus NH4 plus. This is aqueous. This is also aqueous. This is aqueous. This is liquid. In this reaction, H2O is acid, NH3 is base. I already told you while explaining Bronsted acid and Bronsted base. This is base. This is acid. This is called conjugate base. What type of base? This is conjugate base. This is conjugate acid. So I told you on OH is called acid base pair. NH3 and NH4 plus is called conjugate acid base pair. Conjugate acid base pair. Conjugate acid base pair is differ by single proton. It is differ by single proton. Yes. This is also called a conjugate acid base pair. So in this case, water is as NH3 acts base. So water donating towards to NH3 one hydrogen atom, it becomes OH minus and NH4 plus. So this is called acid donor. That's why it is called acid. Proton donor. This is proton acceptor. That's why it is called base. This is called conjugate base. This is called conjugate acid. Now here acid water. Water react with H2S. Please listen in this case. Water react with S. Here what will happen? H3O plus will form plus HS minus will. Here water acting as an acceptor. That's why it is called base. Lowry-Bronsted base. This is called acid donor. Donor this is. This is called conjugate acid. Conjugate acid. This is called conjugate base. So one place water acting as an acid, another place water acting as a base called amphoteric substance. Amphoteric in nature. Please complete fast. It's completed. Next, one more reaction, last reaction, please listen. Autoprotolysis. What is the meaning of autoprotolysis or self-ionization? What is the meaning of self-ionization? Water react with H2. This is acid base. So this is called donor, proton acceptor. One hydrogen atom donating towards to this one. It becomes H3O plus. This is called conjugate acid. And this is becomes OH minus. This is called conjugate base. Conjugate base that is. I hope this one is clear. Now this is called autoprotolysis, otherwise it is called self-ionization. Autoprotolysis, otherwise it is called self-ionization. Next, react with the metal. React with metal. Generally, sodium react with metal. Sodium is solid, react with water. Will give rise to sodium hydroxide will form plus hydrogen gas will. Sodium react with water will give rise to sodium hydroxide. Please listen one more point. Copper react with water will not any equation. No equation. Iron react with water, no hydrogen gas will liberated. But the sodium react with water, sodium hydroxide plus H2 gas will liberated. That means sodium can displace H2, but copper cannot displace hydrogen. Iron cannot displace hydrogen. Mg can displace. Mg react with water will give rise to MgOH taken twice plus hydrogen gas will liberated. That is, a magnesium can displace hydrogen, but hydrogen cannot displace magnesium. Copper cannot displace magnesium. Even zinc react with water will give rise to zinc hydroxide plus H2 gas will form. Zinc can displace hydrogen, but hydrogen cannot displace zinc. Is this clear, these points? Water can easily reduce to dihydrogen by highly electropositive metals. See, sodium is highly electropositive, magnesium is highly electropositive, zinc is highly electropositive. This is low electropositive metals. Yes. Remaining topics I will cover tomorrow. Remaining chemical property also I will discuss tomorrow.
Okay, sir.
Thank you. I'll inform to you timings. Tomorrow I will inform to you what timing I will take the class. Can I end the meeting? I'm going to end the meeting.